Express 140 as a product of its prime factors. So 140, you do your short division. So it is 70, 2, 35, 5 into 7, and 7 into 1. So 140 can be written as 2 into 2 into 5 into 7. Don't write 1 because 1 is not a prime number. You could also write it as 2 raised to 2 into 5 into 7. Find the LCM of 12, 15 and 21 by prime factorization. So when I do 12, the prime factors of 12 is 2 square, that is 4 into 3. Prime factors of 15, 3 into 5. Prime factor of 21, 3 into 7. Now to find the HCF, we need to find common factor which are common throughout and the lowest power. Now if you see 3 is common in all, so I'm going to write 3. So here is 3, and the lowest power here is 3 raised to 1, so it is 3 raised to 1, 3 raised to 1. So lowest power is 1. So the HCF equal to 3 raised to 1, which is equal to 3. To find the LCM, we write all factors and their highest power. So here we see the factor. There is a factor 2, there is 3, there is 5 and there is 7. And the highest factor of 2, if you see, highest factor is 2. Highest factor of 3 is 1, 1 and 1. Highest factor of 5, 1 and 7 also 1. So LCM equal to 2 with highest power was 2 into 3 into 5 into 7. So LCM is 420. Find the LCM and HCF of 6 and 20 by prime factorization. So if I do prime factorization of 6 is 2 into 3, and of 20 is 2 square, that is 4 into 5. To find HCF, I have to find common factors which are common, and the lowest power. So you see the common factor is 2, it's there in both. So, and the lowest power here is 2 raised to 1, this is 2 raised to 2. So the lowest power is 1. So HCF is 2. Now to find LCM, we need all factors and highest power. So the factors here are 2, 3, 5. The highest power 2, 3, 1 and 5, 1. So the LCM equal to 2 raised to 2 into 3 raised to 1 into 5 raised to 1. That is 4 into 3 into 5. That is 60. LCM will be 60. State whether 13 over 3125 will have terminating or non-terminating repeating decimal. Now to find out if it is terminating, what is the condition for terminating? The denominator should be in the form of 2 raised to n, 5 raised to m. Means the denominator must have only 2, only 5 or 2 and 5 as the prime factors. It should have no other number besides that. So if I want to decide is 13 by 3125 is it terminating or is it non-terminating? I need to find the prime factorization of the denominator. So the prime factors of denominator are, let's do that, is 3125, and 3125, if you do prime factors, you see it is 5 into 5 into 5 is 5 raised to 4. So when I write now 13 over 3125 equal to 13 over 5 raised to 4. So the denominator has factors only 5. So it should be terminating. So we can write denominator is in the form 2 raised to m, and means it is 2 raised to 0. There are no 2's there, and there are 4 5's. Therefore, it is terminating. State whether 7 over 8 is terminating or non-terminating. So 17 over 8. So 17 over 8, we need to check the denominator. So prime factorization of denominator. The denominator is 8. The prime factorization is 2 into 2 into 2. 2 raised to 3. So 17 by 8 equal to 17 over 2 raised to 3. Thus we see the denominator is in the form of 2 raised to m, 5 raised to n. Why is it in that form? It's 2 raised to 3 and 5 raised to 0. Let me write it here. 17 over 2 raised to 3, 5 raised to 0. Therefore, fraction is terminating. Find the HCF and LCM of 26 and 91 and verify that LCM into HCF is product of two numbers. So we have 26, and 26 you know can be written as 2 into 13. 91 is equal to 7 into 13. Now to find the HCF, we need to write common factor and lowest power. If you look up here, the common factor is 13 and the lowest power of 13 is 1. So HCF equal to 13. Now to find the LCM. The LCM, you write all factors and highest power. Now the factors here are 2, 7 and 13, and the highest power in each case is 1. So LCM is 2 raised to 1, 7 raised to 1, 13 raised to 1, and when you multiply you get 182. This is one part of the sum. The next part of the sum tells us show that the product of LCM and HCF is a product of two numbers. So first I have to find what is LCM into HCF. LCM is 182 and HCF is 13, and this product comes 2366. On the other side, I need to find out product of two numbers. Product of two numbers, and you know our numbers were what? 26 and 91. And when I multiply, I also get 2366. So what have you realized here? That LCM into HCF equal to product of two numbers. Show that 5 minus root 3 is rational. So let us assume that 5 minus root 3 is rational. Now, if 5 minus root 3 is rational, we can write 5 minus root 3 in the form of P over Q, where Q not equal to 0 and PQ are co-prime numbers. Now, when I solve this, I get now 5 minus P over Q equal to root 3. You take the LCM. Q is the LCM. So 5Q minus P equal to root 3. Now here we see that this is the left hand side. The left hand side is 5Q minus P over Q, and this is rational. And on the right hand side we have root 3, and root 3 we know is irrational. And they are equal, but we know rational and irrational cannot be equal. So we got into this contradiction. So, but we know rational number cannot be equal to irrational. Therefore, our assumption is wrong. What was our assumption? Our assumption was that 5 minus root 3 is irrational. So 5 minus root 3 is, our assumption was 5 minus root 3 is rational. So 5 minus root 3 must be irrational. An army contingent of 616 members is to march behind an army band of 32 members in a parade. So let's draw this thing. So first we have a large contingent, and there are here 606 members, and I'm not drawing all of them, but there are all these standing in a row, all these army. Okay, we do not know how many rows there are, that is our question, but we know there are here 616 soldiers, and behind them there is the band. This is the band, and in the band there are 32 members. Here they've given, but this band is also standing in the same line as the contingent. So here is a contingent, and behind them is the band. Now we must know what is the maximum number of columns in which they can march. So let the number of columns say be x. Let the number of columns here, there are x columns here and in the contingent, and there will be also x columns in the band. So they all stand one behind the other. So let the number of columns of column C be x. Now you definitely know x has to be a factor of 616. X is a factor of 616, and x also is a factor of 32. So we can say x should be, x is factor of 616, and since we want to know the maximum number, x is the highest factor of 616 and 32. So in this sum we have to find HCF of 616 and 32. So now we'll find the HCF. To find the HCF we have to do prime factorization of 616, and prime factorization of 616 is 2 raised to 3 into 7 into 11, and prime factorization of 32 is 2 raised to 5. To find HCF we take common factor and lowest power. So the common factor is 2 and the lowest power is 3. So HCF equal to 2 raised to 3, and which is 8. So the maximum number of columns in which they march is 8, is equal to 8. Let me explain the sum, the meaning of this again. So remember we got x equal to 8, means we got x is the maximum number of columns. Now here we had, these were our contingents with 616 people, and we already calculated that the number of rows here should be 8. Therefore the number of in each row, if you see, they will be 77 in each row. In each of this row there will be 77 soldiers, because 77 into 8 will be 616, and behind them were this band, and in the band we know there were just 32 soldiers, but they also remain in 8 rows. There would have been 8 rows here, like this: 1, 2, 3, 4, 5, 6, 7, 8. Here also 1, 2, 3, 4, 5, 6, 7, 8. I think, oh, I do one extra here. This I should have drawn later. So there would be 8 of them. So both had 8, 8. So here too there will be 8. So in each row there would be just 4 of them. But the number of rows, see, it becomes even. Both have the same number of rows. That's why they all travel in a proper design. So 8 is factor of 616, because 8 into 77 is 616, and in this also 8 is factor of 32. So 8 into 4 is 32. So they had to make 8 rows to stand in proper order. Express 156 is a product of its prime. So I do 156 divide by 2, this is 78, divide by 2 becomes 39. Now this divide by 3 is 13. So 156 as its prime factors: 2, 2, 3 into 13, which is 2 square into 3 into 13. Find the LCM and HCF of 17, 23 and 29. So prime factorization is the first step. So it's only 17 because there's no other factor. 23 will be just 23. You can put into 1. It's not prime factor, we just write factorization. So, and then we have 29 into 1. Now to find HCF, we do common factor and lowest power. So common factor you see is 1. Lowest power is 1. So Hcf equal to 1. Now for LCM, all factors, highest power. Factors, all factors 17, 23, 29, 1, 1 and 1. So your LCM will be 17 raised to 1, 23 raised to 1, 29 raised to 1. In fact, it's a product of all three. And this is 11339. Find the HCF and LCM of 12, 36 and 160. So 12 is 2 raised to 2, that is 4 into 3. 36 is 2 raised to 2 into 3 raised to 2. And 160, you do the prime factorization and you'll get 2 raised to 5 into 5. Now we are going to find the HCF. To find HCF, we write common factors and lowest power. And the common factor you see, there is 2 in all. There is 2 here, there is 2 here, and there is 2 here. So the common factor is 2. And the lowest power of 2 you see is 2. There's 2 raised to 2 in this, 2 raised to 2 here, 2 raised to 2 here, and 2 raised to 5. Lowest power is 2. So HCF is 2 raised to 2, which is 4. Now to do LCM, all factor and highest power. The factors are 2, 3 and 5. The highest power in 2 you see here, it is 5, the highest power. The highest power in 3 is here 2 and 5 is just 1. So we have LCM 2 raised to 5, 3 raised to 2 into 5. So that is 32 into 9 into 5. And it is 1440 is the LCM. State whether 6 over 15 is terminating or non-terminating. Now 6 over 15, you'll probably do the prime factorization of the denominator and it will come 3 into 5. Now remember, you have to reduce first before you decide. So you are reducing this. So this becomes now 2 over 5. Now look at the denominator. The denominator is in the form of 2 raised to 0, 5 raised to 1. So it is in the form of 2 raised to m, 5 raised to n, and hence it is terminating decimal. So denominator is in the form 2 raised to m, 5 raised to n, means it is 2 raised to 0, there are no 2's, 5 raised to 1. Therefore 6 over 15 is terminating decimal. State whether 35 over 50 will be terminating or non-terminating. So we have 35 over 50, and if you reduce it by, divide it by 5, you have 7 over 10. Now 7 over 10, denominator, prime factorization of denominator 2 into 5. So it is in the form of 2 raised to 1, 5 raised to 1. So you'll say denominator is in the form of 2 raised to 1, 5 raised to 1. Therefore 35 over 50 is a terminating decimal. Hope you know what is the meaning of terminating decimal. Means you do 35 over 50, you divide it your answer will come 0.7. See, it terminates. So it's called terminating decimal. Find the LCM and HCF of 192 and 8 and verify LCM into HCF equal to product of two numbers. Prime factorization of 192 is 2 raised to 6 into 3, and of 8 is 2 raised to 3. Now to find the HCF, we have common factors and lowest power. The common factor you see is 2. It's common for both. There is 2 here and there is 2 here also. The lowest factor is 3. So HCF 2 raised to 3, which is 8. Now to find LCM, we need to find all factors, write down all factors and their highest power. Now the factors here are 2 and 3. The highest factor of 2, if you notice here, is 6, and the highest factor of 3 is 1. So LCM 2 raised to 6 into 3 raised to 1. In the next part now we've got to show that the product, LCM into HCF is product of two numbers. So let us find LCM into HCF. So LCM or HCF is 8, and LCM, when you multiply this, you get 192. I have not done it here. This will be 192, and on multiplying you get 1536. Next you have to do product of the numbers. Now the numbers are 8 and 192. Here we have 192 and 8, which is 1536. So LCM into HCF equal to product of the two numbers. Prove that 32 under root 5 is rational. So we assume 32 under root 5 as rational, and if it is rational, we can write 32 under root 5 as P over Q, where Q should not be equal to 0. So when I cross multiply now, I get under root 5 equal to P over 32Q. Now my left hand side is under root 5, which is rational, and the right hand side is P over 32Q. All these numbers, P is rational, Q is also rational, and 32 also is rational. So I can write the right hand side is also rational. So this is rational. See, this is irrational, this is not rational. Under root 5 is not rational, remember, it is irrational. So now here I got a irrational number equal to rational, and this is not possible. Rational number equal, this is not possible. A rational can never be equal to a irrational. And why did we get this wrong result? Therefore, our assumption is wrong. What was our assumption? That 32 under root 5 is rational. So we can say, therefore, 32 under root 5 is irrational.